students. Hope everybody's well. I'm a little bummed out because I just found out that the decision has been made by One Day Academy to not continue with live classes this year. Very, very disappointed am I, and I'm very sorry about that. Um, I still would like to try to figure out when the the restrictions are off as far as meeting together. I would like to still launch the rockets. So I think I'm going to go ahead and send rockets so you can build them. But we won't be able to launch them at school. And so by that last week of school, depending on what the recommendations are from our government, I'm going to try to see if maybe we can gather on our own. Okay? So I'll talk to your folks about it and see if they're comfortable with it. We'll have small groups or something like that. But I would really, really like to launch our rockets. Okay. So that puts us today starting this we're studying the space and everything, and we're looking at space exploration. How do we know what we know about space? It's because we've gone there and we've done some exploring. Okay, so we're going to see what it takes to explore space. So we are definitely talking about rocket science today. Okay, y'all are going to be so smart. All right, so the idea of rockets kind of goes back far to the ancient Chinese. They had discovered gunpowder. It's interesting. You think if I asked you what's gunpowder for, probably the first thing you would think would be bullets, which is exactly what we use gunpowder for. But at the beginning, the Chinese did not think of them as weaponry so much as they thought of them as these little fireworks to send off messages. So they were sending messages with these, or making signals or something like this. But they did also use them for entertainment. But then later they found out they could be like weapons, and then furthermore developments came along much later that put the same gunpowder into the bullets that could then fire and this kind of thing. Okay, but still to this day we have fireworks shows that we put on and stuff, and it's made from the same kind of concept. And sadly, the Chinese are who produce most of our fireworks today. I don't know if we should trust those. In America, we have this outstanding scientist named Robert Goddard, who was fascinated with rockets and that kind of thing since he was a boy. And he had an idea of actually sending a rocket out of the atmosphere of the Earth. So he thought, there's a big restriction here on the Earth, and that's gravity. Okay, gravity keeps pulling us down. And Goddard did some calculations along with other people and realized that if you needed to get out of the pull of gravity, you would have to be going very fast. See right here, it tells us 17,500 miles per hour to break the gravitational hold. And so he dreamed that it could be done. He said, I think it could be done. We could get out into space. And other people thought he was crazy. They thought we'll never have that much power to do that. But he did base his stuff on math, so math is useful. There you go. And he turned out to be right. He achieved several altitude records with rockets. And he also came up with the idea of liquid fuel and then solid fuel. Okay, so liquid fuel, solid fuel, those different kinds of fuel for rockets right there. But he was definitely a groundbreaker on rockets. You can see here, I think the rocket's right here, right? He's going to launch that rocket somehow. I can't remember if he actually made it through the atmosphere. I don't think so. All right, after the war, we're talking about the Second World War, there had been lots of innovations having to do with warfare. So weaponry, including, bombs and that kind of thing. And I don't know how much you know about World War II, but we ended the war with Japan by dropping the biggest bomb known prior to that, the atomic bomb. So when we defeated the Germans in Europe, we found some labs they had been working on. In fact, they had developed for the first time a jet engine. It was called the V2 rocket. That was designed, and they didn't really have it. The Germans didn't have it very long before the war ended, fortunately, because it was a very fast plane, right? And it was a rocket plane, essentially a jet plane. It was developed by this man here. So this man is named Wernher von Braun. He's brilliant. He was a Nazi, so, bad news right there. He was working as a scientist the entire time. So when the Germans were defeated, the Americans went in and found their lab and all this stuff, and they decided to make an offer to these scientists. All right, so you may think, how in the world could we hire Nazis? Well, I will tell you this. The president at the time was a guy named Harry Truman. And Harry Truman, they asked the president, Mr. President, we have these brilliant scientists. They've been working on these things. Can we bring them home to be part of our, scientific programs? And he said, as long as they weren't actually Nazis. And what he meant by that, part of the Nazi party. So they assured him that they wouldn't be part of the Nazi party. Well, they were all part of the Nazi party. So it was kind of hard to promise that. My point is that the president didn't know they were Nazis. How about that? Okay. So they kind of sort of kept that a little bit from him. But he wasn't a Nazi in the sense that he was out, shooting people or developing, ways to kill people. Nothing like that. He was just working in a lab. I don't know if this is defensible or not. You tell me. But our option was this. If we did not take him and give him, American kind of protection, if you will, guess who would have? The Russians. And very soon in our history, it turned into something known as a Cold War, where the Americans were pretty much racing against the Russians to develop, warfare things. It was called the Cold War. And so it was really important that Wernher von Braun, brilliant scientist, came to America and did not go to Russia. So this was good, okay? So they brought him home. In fact, the Germans themselves thought, well, who should we do? Should we just surrender to the USA or to the Russians? And they wanted the USA as well. So he came over to America and was absolutely crucial in the developing of our NASA space program. All right, so NASA was put into effect by the next president. His name was Dwight D. Eisenhower. So it was Wernher von Braun then who developed the famous rockets for the Apollo program in particular, but prior to that, some of the other programs as well. This is a long-range rocket. I believe this may have been one of the Nazi rockets right here that he helped to design and develop. And like I said, the war ended before the Nazis could really use this type of rocket. All right, so now we're in this Cold War time period of American history, and it's basically America versus the USSR, which stands for the United Socialist Soviet Republic, communists, And so we entered into this. There was an arms race, arms being who can make the most bombs or rockets or, war-type vessels quicker and how many. The other was the space race. All right, so Dwight Eisenhower established NASA not as a military branch, but as, essentially as a civilian branch paid for by the federal government. But it wasn't for military purposes. It was only for scientific purposes, for discovering what was out in space and making these new advances in space, kind of a thing. All right, so they were rivals with the USSR. One thing they wanted to do, one of their goals was, there were a couple goals. One was to put a man in space, to put a man in orbit in space, and then a long-range plan, which some people thought was a little crazy, was to take a man to the moon. Wow. Okay. So that was sort of the race that was taking place now between America and the Russians. Now, when you're under a lot of pressure time-wise, it's important to not make mistakes, right? So this is very... advanced science, right? This is rocket science, so it's some of the hardest stuff out there. Well, the first step in the race was won by the Russians when they actually put a satellite up into orbit. Here's a picture of it. It's called Sputnik. And Sputnik was launched into the atmosphere, through the atmosphere, up into space, and actually orbited around the Earth for several months. It didn't do anything except it emitted a beep, kind of a beep, that a radio signal could pick up. So it wasn't doing anything, but it was orbiting. So that was, part one goes to the Russians. And of course, the Americans were like panicking at this point. Okay, so before the U.S. could even get any rockets into space, the USSR launched another one called Sputnik 2. Now they decided to put a living creature on it. This is Laika. And Laika was a dog that was put in this little rocket, was trained for it and everything. And they were able to monitor her. She had like little, monitors on her heart rate and that kind of thing, to make predictions if man could actually go to space. Was it possible? Sadly, they did not devise a plan to bring her home. So she just stayed out there in space, y'all. Yeah. Very sad, and she died out there. Eventually, the idea that what goes up must come down is actually true. So eventually stuff in space does fall down to the Earth, and it did at some point. I haven't heard specifically when Laika came down. So, but the United States decided they wanted to try something, but not like that. That's very bad press to send a poor dog into space. So the USA decided to send a chimpanzee. Now, the idea that a chimpanzee is a primate, and humans are considered primates, yes, and so it would have many of the same body features that men have, that humans have. I mean, dogs do too, right? They have heart, lungs, all that kind of thing. So they decided to train this very special chimp named Ham and send him into space. And he was called the Astro Chimp. Okay, so let's see what America did about this.
This chimpanzee will pave the way into space. His name is Ham. He has a different training regimen than human astronauts, including shocks to his feet if his attention strays from the instrument panel. But his job is paramount. Prove that a primate can function in space.
So this was how you were able to, what they would have called at the time, man-rate the vehicle.
All three start final lights are correct. Mercury go, and Mercury lights on. T-minus 18 and counting.
Since the embarrassment of Mercury 1, they think they fixed the rocket.
Minus 10, 9,
But will the capsule keep Ham alive?
6. 0, 1 second. Lift off. Lift off.
Mercury 2 punches through the Florida sky,
5-7.
with the hopes of the program riding on a 3-year-old chimp.
We are great. Correct. Roger.
The capsule loses pressure,
Flight.
but Ham's spacesuit keeps him alive.
Ignore. We shouldn't fix it full scale. We'll keep an eye on this.
He pulls levers and pushes buttons as trained.
We lost our pitch. Ignore.
They know he's conscious, but don't know if he'll endure re-entry.
Let us know when you regain the signal.
Ships find Ham's capsule in the wide-open Atlantic. They whisk it aboard and open the hatch to see if Ham survived.
He was a little dehydrated, he was a little fatigued, but they gave him an apple and he liked that.
He has nothing more than a bruised nose. Everyone hopes the first human in space will be so lucky.
All right, how about that? So Ham did great. I believe that when they said spacesuit, they meant that little chamber thing that he was in right there. He spent the rest of his life in a zoo, living the high life. All right, what about men? Okay, so the Russians beat us with the satellite. They beat us with the animal in space. Well, they beat us with a man in space too. The first man in space was a Russian cosmonaut. Our guys are going to be called astronauts. But the first cosmonaut, so officially the first man in space, is Yuri Gagarin. There he is over there. He is sometimes attributed with a quote that is incorrect, and that quote was, "I looked and looked and looked and saw no God. And I did not see God out there in space." He never said that. Some people have said that because the Russians are, typically atheists, but apparently he never said that. He came back safely, and he went on to continue work in the Russian space program. But in America, we got a group of guys together that went through some pretty rigorous training in order to become part of what would be known as the Mercury program. And so here is Alan Shepard right here. He's the first man in space. So the Mercury program is named after the Mercury rocket, which you saw was the one that took Ham into space. And apparently at the beginning they had some trouble with that launching, so they had to work out the kinks. So that's why rocket science is so tough, right? Because there are things that, when things go badly, then they can go really badly, right? So people can die. And that's why we had to do so much testing and testing. I will say this, that over in Russia, they apparently had some accidents, but they never told us about them, all right? So they just kept those under wraps. So we never heard about the bad things that happened with the Russian program. All right, while Alan Shepard was the first American in space, it was John Glenn who was the first American to orbit in space. So Alan Shepard went up and was in space and came back down. John Glenn went up and then orbited the Earth several times before coming back down. And it was very successful. Everybody came back safely, no trouble whatsoever. All right, now getting a man to the moon, however, would be a bigger challenge. Okay, so the idea here is that we have to get a rocket that would reach that speed to break the Earth's gravitational pull. We figured that out with our Mercury rocket. We got our guys up in space. We got things into orbit. We would soon use rockets like that to put satellites into orbit. But going to the moon was going to require more. Okay, so first of all, we need more room for the people, right? So for instance, the next program that came into for America after the Mercury program was called the Gemini program. Gemini meaning twins, because 2 men went up. All right, so these 2 men went and they did some pretty miraculous things. They went outside of the capsule and did what's known as a spacewalk. So Ed White was the first American astronaut to do a spacewalk, and then they would come back down. So that was the Gemini program. Then came the Apollo program. So the Apollo program is the idea of getting to the moon, and this would have 3 men in it. All right, because they realized they needed 3 men to handle the 3 jobs, you know, so the 3 different things, you know, there'd be a commander and then there'd be his 2 other guys. And so this was going to require more firepower because it had to lift more men. It was going to require, they were going to take with them something to land on the moon with, so that's heavy. They got to take that up there. They had to have their capsule to come home in, and plus they had to have the way to get that capsule with the landing module in it all the way to the moon, right? So this is going to take a lot more power. And so what Wernher von Braun came up with, which was brilliant, was the idea of the Saturn V, which would have stages. All right, so there'd be the first stage, which is this big part right here, these engines that would, break the bonds of gravity, right? But then we have several other stages here. All right, what this picture is you're looking at here, this is in Houston. If you've been to NASA, you've probably seen it. This is a Saturn rocket, okay? The reason why it's here is because it never went to space. This one was supposed to go up for Apollo, I don't know if it was 17 or 18, one of those, and they ended up scrapping the mission, I think mostly due to money. It was going to be too expensive or something was going on right here. So now we've got that where we can go look at it. You see how huge it is? You can walk around it right there and you can see those different stages. I don't know if you can go up inside there. I can't remember that. I have no idea what that is. If you're one, it looks like a giant hat, doesn't it? I don't know if that's really there or if somebody did like a photo edition on that. I'm not exactly sure. Maybe one of you knows and you can tell me that. So anyway, the Saturn V is the rocket that's going to go. There's Wernher von Braun with the rocket in the background. Very proud of his invention there, and it's going to turn out to be a massive success. All right, so now we have a race to the moon. I will tell you this, something really interesting that you may not know, and that is that the Russians did have a moon plan too, and they actually sent a rocket up there before our guys landed. They actually landed something, it crashed. But anyway, it did get up there. But no people were on it. It was unmanned. Okay, so nobody was hurt as far as we know there. Okay, so the Apollo program is going to now look at a manned moon landing. And the Russians, like I said, they had already seen the dark side of the moon with photographs. But it would be the Americans who actually made it to the moon. Okay. There was a lot of research and experimentation that had to do along the way here, including some tragedies. Apollo 1, for instance, actually the 3 astronauts, I believe this is them right here, because that is Gus Grissom. Gus Grissom, Ed White, and Roger Chaffee were just practicing some things in the capsule while it was on the launch pad. It was not in space. It was sitting on the launch pad on Earth, and something happened. There was a spark, and because there was a lot of oxygen inside the capsule, it caught on fire. It was on fire, and it burned very quickly, and all 3 men perished, which is obviously a huge tragedy. And then it scrapped the program for a little while. This is actually the picture of the capsule where the men were. As you can see, that was a intense fire. Yeah, no chance of survival there. It was horrible. The entire world, country mourned this situation. And for a little while, the Apollo mission was scrapped until they figured out what in the world was going on. But they picked it back up, had several successful journeys outside. One of the missions actually went around the moon completely and came back, but it fell to Apollo 11. So 11 times, right, when they finally got to the point where they were going to have men landing on the moon. So it was July 1969. In fact, 2019 was the 50th anniversary. So last July was the 50th anniversary of this incredible feat of human endeavor. They made it to the moon. So here are the three guys. And there had been several astronauts, and they didn't know which ones were going to be selected for the mission. And furthermore, they didn't know who was going to be selected to be commander of the mission. So it fell to Neil Armstrong to be the commander. Why is that important? That's important because he would be the first guy on the moon. Okay? And then one of them's the pilot. That is this guy. His name is Michael Collins. Most people forget his name because he did not go step on the moon. He waited for these two guys. But Buzz Aldrin, right here, he was a big hero, and he's still alive, I think. Yeah. He, of course, was the model for Buzz Lightyear. Okay. So they actually made it up there. They followed every bit of training they had, and it was a huge success. All right. So Michael Collins is out there waiting for them. These two guys go down in the lunar module. Let's see what kind of... Yeah, here's one of the photos they took. Isn't that great? I don't know if this was Apollo 11, y'all, if that's where this photo was taken, but certainly from one of the Apollo missions. And you can see that is called Earthrise. So that's the Earth rising on the horizon of the moon. Very, very cool. All right, let's see what this video tells us.
Okay, all flight controllers coming up on auto sequence. Booster, how you?
We're go flight.
Econ?
Go flight.
GNC?
Go flight.
Telcom? Go flight control?
Go.
Network, you got it all? Got it all?
Inspired by the late President Kennedy, in only 7 years, America has risen to the challenge at what he called the most hazardous and dangerous and greatest adventure on which man has ever embarked.
2 minutes, 30 seconds and counting. We're still go on Apollo 11 at this time. 10, 9, 8. Ignition sequence has started. 6, 5, 4, 3, 2, 1, 0. Liftoff. We have a liftoff. Power cleared.
separation.
We show capture and hard dock. Congratulations.
Houston, we've got a good separation.
LM is the lunar module. So they're towing the lunar module now.
Undocking confirmed.
Two astronauts are in the LM now, and Michael Collins is in the command module.
Eagle Houston, we rig you now. You're go for PDI, over. Roger, understand.
That's Neil Armstrong talking to command in Houston.
Roger, copy, throttle down. Set him in the simulator. Roger. You're looking great to us, Eagle. Eagle looking great, your go. Roger, 1202, we copy it. Altitude, velocity, light. 8.5 down, 20 feet. 15 forward. 11 forward, coming down nicely, 200 feet. 4.5 down, 5.5 down. 100 feet, 3.5 down, 9 forward. 5%. Okay, 75 feet. Car's looking good, down a half. 6 forward. 4 forward, drift into the right a little. 20, down a half. 30 seconds forward. Contact light. Houston, Tranquility Base here. The Eagle has landed. That's one small step for man. One giant leap for mankind. Tranquility Base, this is Houston. Could we get both of you on the camera for a minute, please? Neil and Buzz, the President of the United States is in his office now and would like to say a few words to you, over. Would be an honor.
Tranquility Base, Houston.
Roger, go ahead.
Roger, our guidance recommendation is pings, and you're cleared for takeoff.
Roger.
Roger, understand. We're number 1 on the runway. Roger. Proceed. Channel, beautiful. 26, 36 feet per second up. 5 for the pitch over. Very smooth. Very quiet ride. There's that one crater on there.
Undocking confirmed. Got a good separation.
Okay, wow. That was amazing. So let's talk a few things about that. Okay, so first of all, I don't know if you noticed in that video right there, but when they were landing the lunar module, so here is, this is actually Buzz coming off the lunar module right here. I know it's Buzz because Neil Armstrong took that picture. When they were coming down to land on there, they had chosen ahead of time the spot on the moon where they wanted to land, and it was called known as the Sea of Tranquility. And they thought it's called that because it's very smooth. But when they got over it, Neil Armstrong, the pilot of the LEM, noticed that it wasn't as smooth. It was more of an angle than he thought. So he had to move away from that spot and find a different place. So if you notice, it was almost like a video game. He said 2 over, 1 down, 2 over, 3 down, 3 ahead, something, whatever he was saying, because he was moving a little bit. And the guys in Houston started getting a little nervous. And at one point, I heard it on there. You can go back and try to listen to it. They said 30 seconds. All right, because he was running out of time. And it was time was critical here, because if you think about it, he's using some fuel to land this thing, right, to bring him over the right spot and this kind of thing. He was going to need some fuel to blast off to get back up to the command module. And they're thinking if he uses too much fuel now, he won't have enough to get back to that command module. And so they're like 30 seconds, but he got it landed in time onto a nice safe spot. It all worked well. And I don't know if you may have noticed that Neil Armstrong was cool as a cucumber. He didn't panic at all. He was just very calm and cool, which is part of the requirements even to this day. If you want to be an astronaut, you still need to have that real, under pressure, kind of calm under pressure, kind of an attitude. So another thing is that when they had calculated landing on the moon, they built the LEM with some really long legs because they were sure that the dust on the moon was pretty thick. And so they built these long legs with sort of discs on the bottom, so it would sort of like a snowshoe, right? So it would land on it, but it might compress into the dust a little bit and be kind of too deep, And so if you notice here with Buzz coming off of there, notice the last rung is quite high, right? And that's because the legs of the LEM didn't go as deeply into the moon's surface because, lo and behold, the dust surface on the moon wasn't as thick at all that they thought it was. How had they come to that calculation? Well, they thought if the moon were millions and millions of years old, there must be, a pretty good amount of dust on it. So one of the first things he tested when he got down there, is Neil Armstrong reported back to Houston, he said, well, the dust is about 2 inches thick. So it wasn't very thick at all. They were surprised by that. Okay, I'm not really surprised by that. Anyhow, so he had to jump. He had to jump down off the bottom of that. So when he landed, of course, when he first landed the LEM on the moon, he said, "Tranquility Base here. The Eagle has landed." Okay, so the Eagle was the name of the LEM. And then they were on board there for several hours, just making sure, getting everything right, getting everything in order before Neil Armstrong actually got out to make the walk on the moon. And this is his famous quote for getting onto the moon. He said, "One small step for man, one giant leap for mankind." And what was really cool is we were seeing this back home on TV. I was a kid at the time, probably younger than you are right now. And I remember seeing it. It was not in color. I think probably because we didn't have a color television set, I guess. I remember watching it in black and white. And so it was, one of those really cool memories right there. So this also is Buzz Aldrin right there. And if you saw this up close, you would see a reflection of Neil Armstrong right there. So the really good pictures we got back from the moon were the ones they took when they were there with their cameras. The transmission back to the Earth was pretty poor quality because it was going from the moon all the way to the Earth. That's a long way to go. But they had some really great pictures from the time they were on there. And you saw when they got back, all those steps that had to be taken to get those guys back to the Earth. I mean, that is extraordinary. That is where science really pays off, y'all. So really awesome. Later space day there were more moon landings. I'm thinking, let's see, 1, 2, 3, 4, 5, 6. About 8 different men have walked on the moon. You could look that one up and see if I'm right on that one. And then, like I said, that last Apollo mission was scrapped. So they started, well, was there anything else for us to do on the moon? Had we really pretty much exhausted? We took a moon vehicle up there, that they drove around on, like a golf cart looking thing. And by the way, all that stuff is still there. The flag they put up there, it's still there. The footprints are still there, maybe very slowly over time getting filled in with some space dust that's hitting it, little dust from space. The same dust that when it hits us, it makes a shooting star, right? That's the same thing hitting the moon. But later on, we thought, well, we've exhausted the moon. I will tell you, there has been talk about going back to the moon. Yeah, so maybe in your lifetimes, maybe one of you can be an astronaut that goes and walks on the moon. The reason they've been talking about it is to sort of make a base for the possibility of maybe traveling to Mars. Also, there might be some stuff up there that we could mine, some sort of precious materials that we could use from up there. We don't know. So I don't know. You can look that up and see if what the possibilities of a moon trip might be. But later we decided to send up other space travel equipment, and these are called like space stations. So this was the first one in the 70s called Skylab. And if you go to NASA, you'll see a really great exhibit on Skylab. There's a guy, spinning around and this kind of stuff. If it's the same way, I haven't been to NASA in some time. But what we wanted to do is we wanted to do experiments that would see how does man last under, time with no gravity. What does it do to him? This kind of thing. I will also mention to you, as far as the guys coming back from the moon every time, when they came back, they were put in isolation for 2 weeks or so, maybe not that long, to make sure that they hadn't brought back any, moon bacteria. Turns out there was no living things up there that we know of. They did bring back moon rocks, however. So these guys were just doing various experiments. This one is the one, I believe this is one that's still up there, the ISS, the International Space Station. And what's nice about this one is that we're sharing that with other nations. So we have Russians and Americans and British and French and Israelis going up to the International Space Station. And they're all doing their separate little experiments, and we're all learning from it together. So it's one of those things where the world kind of gets along. In fact, I think I remember just today, which is Friday, one of our astronauts, a female, just came back, like today, from the International Space Station. And they landed in, I don't know, in Russia somewhere, I think. So the Russians were the ones the Russians apparently are the taxi drivers to the International Space Station. They're the ones that take people up. We did for a while with our space shuttle program. We don't do that anymore. So what is it like out there in space? Well, first of all, there's no gravity. So everything's floating around all the time. You have to be real careful, especially with liquids. You don't want water to be to hit a computer, because you don't want water on your computer, do you? Well, neither do the astronauts. Their food has to all be packaged up. what they'll usually do is it'll be dried and they'll add water to it carefully so the water doesn't escape. So these would be called freeze-dried foods. When I was a kid and the astronauts were first going up, they had invented freeze-dried orange juice. It was called Tang, right? And so that was all because it could be taken up and reconstituted up there. They also had different types of space food. I'll show you some of that. All right, this is a little video about the International Space Station.
Good morning to the International Space Station. Today, me, Frank de Winne, together with my international crew, we are ready for another busy tasking day in the International Space Station. Like everybody who gets up to get to work, we first need to clean up a little bit. Now here in the space station, this is not so easy as we would do on Earth. We don't have showers, we don't have baths, and for sure we don't have a lot of water. So everything we do with minimal water possible. So in the morning we just freshen up a little bit, because during the day we do a lot of sports, and of course after the sporting sessions then we wash more properly. So let me show you how we will freshen up in the morning. First of all, we take our washing clothes, we have a bag with water, and this is what we use to freshen up. And yes, we have a very small bathroom here, which is just to the right of me, so let's have a look in our bathroom. As you can see, not very luxurious, but still, it's enough space for us to do what we need to do. So, water is also very dangerous on the space station, because we have a lot of electricity, so we need to be very careful not to spill it. So we just put a little bit in our washcloth, as you can see here. And with gravity, of course, you can form nice bubbles and they can float away. That's why we need to be very careful. Here I'm just making a demonstration, but usually we don't do it like this. Usually we let all the water straight go into our washcloth and then we close it immediately so that we can't spill anything. And now it's washing time. As we said, it's just freshen up in the morning, so it will not take very long. So, that's about it. And now, of course, we also need to brush our teeth. This is very important as well for our health. Also here, we will use very little water. And we have also a very special technique. We still use a normal teeth brush. And we also use normal toothpaste. Again, we will be very economic with everything we are using on board of the space station. Just a few drops of water. As you can see, they are coming out here on my toothbrush. This is all we need. Some are floating away, so I'll try to catch them with my toothbrush. This is more than sufficient water to brush our teeth. Also toothpaste, we will use very little. On the ground as well, we often use too much toothpaste for what we need. So let's just use a very tiny little bit. More than enough. And now, it's actually like at home. However, I can't talk. As you have seen, when we are finished brushing our teeth, we can't use water to spool our mouth. So we just get rid of the toothpaste in a small cloth like this, which of course after a while we exchange. And then we use a little bit of water again to clean our toothbrush, because of course we need to keep it clean. So we use a little bit of water. There it goes again. Oops, here is a drop. That's it. And with this bit of water, and again our small clothes, we can clean our toothbrush, which we can replace regularly here on the space station. It's clean and we can use it tonight. So, That was most of our morning routine. Of course, we also need to get dressed, and we also need to use the toilet. The toilet here is the same place as I was in before. It's also totally different than when we go to the toilet at home, because we don't have gravity, so we need a ventilator to be able to make all the fluids and all the nasty odors going away. This is the tube that we use to urinate, and we also have a small toilet here to use for the bigger bathroom. But of course, like at home, toilets are private, so I'm sorry, here you will have to miss the movie. Talk to you later. Bye. Today, my task is to sample the water that we have here on board of the ISS. Indeed, clean drinking water is very important for every human being on Earth, but also for us in space. This may seem obvious to us in the Western world. However, plenty of children, especially in defavorized countries, do not have access to clean drinking water. This is why, in this ESA mission called OASIS, we pay also special attention to water. And this is also why, as a goodwill ambassador of UNICEF, I support their WASH campaign that is there to help millions of children get access to clean drinking water so that they can have a nice future. Today, you see me here taking samples in the Russian module of the warm and the hot water. Later today, I will also take samples in the American segment, and then I will also analyze this water here on board of the ISS. We have a lot of equipment to make sure that we have clean drinking water. And also on the ground, a lot of specialists are helping us to make sure that we have good water and that we stay healthy. So I also hope that you can help UNICEF and other organizations to make sure that children all over the world have access to good and clean drinking water.
Okay, so you get that, and notice how he had to stick everything like with Velcro onto everything, right? So that was a way to keep everything from floating away. So it's kind of funny when they go to sleep, they have to strap their arms down, otherwise their arms would be floating up. All right, we also had the space shuttle program. Like I said, it's no longer functioning. It was it was ended by the Obama administration. But what it would do is it would take this huge rocket here. This is holding the fuel right here. This huge rocket would take up the shuttle itself, which would then return. So that was pretty cool. We had to jettison these things right here, but they usually fell in the ocean and we could find them and reuse them. So we started thinking a little more about recycling and things like this. So we'd bring them back, and here, so it essentially is like a giant glider. So once it was in space, it could move around in space, but when it came back, it couldn't fly on its own. So this is the way they got it. So it would take off from Florida, land in California, and then they would take it with the airplane between California and Florida, get it ready for another mission. I remember before seeing this when Bergstrom was still at Air Force Base. I remember seeing this. They landed in Bergstrom to get refueled for this plane. Pretty cool stuff. They learned lots of stuff from it as well. All right, other space endeavors. We've learned about the Hubble Space Telescope. We've seen what great things it's done. We've sent out probes, one of them called Galileo, that went to Jupiter. We've sent out, there's still some out there taking pictures of the way out of space, and we finally got pictures of Pluto, I guess 1.5 years or 2 years ago. So there are definitely still lots of space exploration going on. And now, of course, they're talking about a moon thing. Your book is going to tell you a little bit about this cool thing called inflatable spacecraft and how those can help with, space, getting things up there, weight. It's not as heavy when it's on the Earth, kind of a thing, and then maybe more sustainable than all that heavy stuff that eventually will fall out of orbit. So read that little article in your textbook about these really, really cool new cutting edge spacecrafts. Here's an idea of what one of the inflatable ones would look like. Pretty cool. Yeah, and so they're still doing all sorts of research. They're not just up there living and having fun. They're doing research, doing scientific things. And so if you wanted to be an astronaut, you could do something like that. All right, going way back in history, we have some other people where we talked about Goddard and rocket travel and stuff like that. The idea of what was happening in space and why space was acting the way it was, there were lots of men who went before who helped us to understand these things. And Johannes Kepler is one of those. You have in your book a short like biography on him. Here's a quote, the diversity of the phenomena of nature is so great and the treasures hidden in the heavens so rich, precisely in order that the human mind shall never be lacking in fresh nourishment. I like that. He was also a very strong believer in God and attributed all of the fascinating space truths out to God. So he was pretty brilliant. He was helped with Tycho Brahe and his work on establishing the orbits were in an elliptical form, and he came up with some laws of space as well. But it's Isaac Newton who came up with the laws of motion, which is what our lab is going to be about today. So that little, that's his picture to the left, but to the right, that's called a, what is that called? Newton's cradle? Yeah, Newton's cradle. And I have one of these, and I would have brought it to class for us, because they're fun to play with, right? It's just all about momentum and how the momentum is conserved till the end there, that kind of thing. But Newton was the one who came up with the laws of motion. There are 3 laws of motion, and the one we're concerned about is the third law today. The third law states, for every action there is an equal and opposite reaction. So if I push with my rocket this direction, my rocket itself will go this direction. Okay? That's how rocketry works. So I'm going to play for you a little video here about our lab today, what we're going to be doing. Okay? And then remember, we're going to be Zooming next week, so hopefully we'll be able to do part of this lab together. Let's just see. Hey everybody. Okay, here we are. I have a couple of things for you for our lab today because we're learning about rocket science and travel in space and things like that. Hopefully at this point you have the little rockets I've sent with home, I hope. The first one here is one that I'd like to do like during our class time, okay? So when we're Zooming, maybe we can do that. So what you're going to do is you're going to take, this is like a syringe, right? You're going to put some water in to about the 10. Now, I just did this experiment with my granddaughter over Easter, and we discovered that less than 10 actually worked better. So between 5 and 10 worked really, really well. And then you're going to take one of these fizzing tablets right here, open that, and it fits right over that little thing. So you'll hold it like this, the water will be there, fizzing tablet there, and then we also discovered this goes on nice and tight, okay? And then you're going to set it down. Can't see it, set it down, and you're going to run away. Run away and then look back and see what it does. Don't stand right over it, okay? Maybe if you have some sort of goggles or something, that would be great. If we were doing this together at school, I would have goggles for all of you so there would be no injuries, anything like that. But as long as you just stay a few feet away from it, it should be fine. And it'll blast off, okay, under the principle of the third law of motion, right? For every action, there is an equal and opposite reaction. Okay, so hopefully we'll get to do that together in our Zoom. When I send it home with you, I'll have this little instruction sheet that tells you how to do it. And furthermore, we also discovered that sometimes it'll blast off, and then we can take that very same tablet and put it in and do it again. And then we have a second tablet in here. So you should get like 4 launches out of the deal. And then perhaps maybe your folks have some more fizzing tablets, and you can use it over and over again, okay? There you go. So that is one of the rockets right there. The second rocket we're doing today is our straw rockets. Okay, so I sent you with a couple of straws. One's a bendy straw, and it's smaller. Then another colored straw goes right over the top like this. Okay, so what you're going to do is you're going to take your colored straw, and you're going to fold it over, just like that. And then take a piece of tape. So you'll need some tape, and just tape it closed. Tape it closed, like that. And now it's closed on that end, right? So now what you have is a little launcher and a little rocket, and you can count down. There it goes. Okay, so it just, did you see it? Let's try again. So what you may want to do is maybe decorate it and make it into like a fun little rocket shape. So by the time we get to class, everybody can show me your rocket, and then we can blast them off. Now, at class time, I always have to be very, very strict to tell y'all never blow them at each other, okay? Because this could be a problem. You always just blow them up, right? And so I let you take them home with you and everything, but I'm trusting you not to aim at your siblings or anything, or your cat or your dog. You know, it's not a weapon. We're learning about rockets, okay? Rockets for travel, right? The other thing I had for you, so if we do get a chance to get together to launch our big rockets, which I'll show you in a minute, because we need to get started on those. I was going to have this for you. Look, you know what this is? It's astronaut food. You know what? It is an ice cream sandwich. It's freeze-dried, right? So I would break it up and give you little pieces. I have a couple of these. I was really excited to see if you wanted to try these. I'm not going to open it because I don't want it to go bad. So, because I'm hoping we still get a chance to get together to see it. Okay, I'll be back in a little bit with the big rockets. Okay. All right, so hopefully we got to do this little experiment together. And I get to see your little straw rockets and things like that. I don't know how well we'll be able to zoom the Seltzer rockets, because you have to do that outside. So y'all will probably all be inside of your computers or whatever. What I will tell you about that, why is the little fizzy tablet doing that? So what happens is the fizzy tablet is made so that when it mixes with water, it starts to dissolve it, and there's gases trapped in there. And those gases will start to fizz out, okay? So you've probably seen that. If you drop it into a glass of water, it'll get real fizzy. In fact, those are actually medicine, right? You put them in there and you drink them, and it's like medicine if you have a cold or something. So what happens, it's creating bubbles, and as those bubbles are building up inside that tube, they'll build up and build up and build up to where it's going to have that ability to have so much gas it'll pop it, right? And so then you pop it, it's faced with the top part of it down, and so that reaction will push the rocket part up, okay? So this isn't just physics as far as the laws of motion, it's also chemistry, because chemistry is happening in that little tablet right there. Okay, we're going to see about our other rockets now. Okay, this is the rocket kit I'm going to be handing to your folks, okay? And the very first thing you're going to do is you're going to open it, and you're going to make sure all the parts are in there, okay? Everything's going to be in there except for the tail fin, which will be separate. It looks like this, okay? So I'll have you this and this. And it also will not have the engine, because I'm keeping the engine. All right, so the first thing you do, open it. You're going to look at the front of this paper right here. Now, this is very important. Do not lose this, okay? Don't lose it. But right here it tells you all the parts, so make sure all the parts are in there. If you are missing a part, let me know, okay? Chances are you'll actually maybe have an extra piece, because sometimes they'll put extra pieces in there. And so hopefully we'll have all the parts, all right? So what I'm going to do is that we're going to go through. So normally what we would be doing is each week I would bring them back for you, and we would do the next step in the deal. So today we're just going to do this top part right here, which is going to be taking our little tube and inserting this clip onto it, and then the clip's going to have this little cardboard over it and then cardboard in it. So what you're going to need for this, you'll need some glue, all right, and you're going to need your folks to use a sharp knife to poke a little hole in this right here, okay, for this part of the metal thing. Can you see that? Right there. It's going to go into a little part that you poke a hole in. And it's important, you're going to need also a ruler and something to mark with, because you need to put it at a certain spot. All right. So what I'm going to do is that I'm going to do that and take a picture of it, and I'll talk you through it so you can keep it nice and slow. You don't have to worry about this video going too fast. All right. So our first thing is this part here is the assemble engine. This is the engine mount. Okay. The engine will end up in here. Then you're going to end up after that. Now you can continue on making it with your instructions right here, especially if you've got somebody at home who likes building models that wants to help you, okay? Because then you're going to take this part and you're going to have to draw a line on it, and you're going to put the little tube on here. It's going to be, because it's going to sit on a little launch rod and a pad, and it'll launch up like this, okay? So that's going to have to be glued on nice and straight. But every week I'll tell you the next step of what we're going to do. So if you want to see what it's going to look like, it's going to look something like that. Okay, notice plain white, which is kind of nice, which means you can decorate it any way you like. Furthermore, there is a thing of stickers right here that you can put the stickers on there, okay? And they wrap around, and do something cool like that. It's going to be up to you. The only thing is you have to make sure you're not going to stick, this does not glue to that. Okay, just make sure. And when we get to that, I'll tell you that. This will glue on here, and then our engine mount that we're working on today will end up inside there, okay? Then the engine will be inside there, because the engine will make it, shoot up that way. All right, on here, though, this is going to come off, and it's kind of cool. We'll knock this little piece out, I guess, I'm thinking. And we're going to have a parachute, all right? So we'll be able to capture them. All right, so I'm going to finish the video now, but I'll come back with just some pictures and tell you the steps that we're going to take on getting that engine mount ready, okay? All right, guys, see you soon. Bye. Okay, y'all, I apologize. I forgot to actually take the pictures of me doing this, so I just put the instruction sheet up there. You're going to take that small tube and you're going to mark it. See right there with your ruler, right? You see how you're going to mark it to 1 inch, right? So 25 millimeters right there. And then you're going to have your folks help you cut, and also the other mark over there where it says A right there. Then you're going to have your folks help you cut that slit into that small line at the very top right there. And then you'll see how that clip will fit down over there, and the little edge piece will go into that little, it'll go into that little slit right there, okay? And then once that's in, it'll be lying flat, and then that ring can fit over the top of it. All right, so once you get that ring over the top of it, you see you're going to put a little glue under there, and that ring will be right here where that mark is and glued on. And then lastly, you'll take the smaller ring, put a little glue on that. It looks like it wants you to put glue right here, and then let it go in there. Okay, so that's the step you're doing this time. You're going to set that aside to dry, and then next week we'll have our next step. But like I said, if you want to continue on, you go right ahead. Okay, guys, thanks so much. Oops.